Okay, welcome. We have now case 2 for the electric flux through a cube using the solid angle, right? Now here I have taken a cube and the charge is resting on one of the corners of the cube, right? So here is the charge. Now we have to see what is the flux through the different faces of the cube. We have two methods to solve this. First is the usual method, that is using the Gauss's theorem, or we can say what is the contribution of the charge in the cube when it is in at the corner. Now, flux through faces that contain charge is zero. We have here three faces. One is this base, second is this front face, and third is this face. These three faces contain the charge, so electric field lines through these three faces will be parallel to the plane of the faces, so there is no flux through them. The flux is zero. Now only three faces are left. One is this face, second is this face, and third is the top face, right? So field lines will cross only through these three faces, so total flux is equal to charge enclosed. We have already seen when the charge is resting at the corner, we need 8 cubes to enclose the charge completely. So contribution of charge in each cube is equal to 1 by 8. So charge enclosed is q by 8. So then phi total is q enclosed by epsilon naught, that is q by 8 epsilon naught. Since the flux is equally going through the three faces because they are symmetric with respect to this the charge, so 3 phi face is equal to q divided by epsilon naught. So flux through the face is q divided by, it is 3 into 8 epsilon naught, that is 24 epsilon naught. So flux through each face is q divided by 24 epsilon naught. Now the question is, can we do it with the help of solid angle? Yes, with the help of solid angle method, we can find the flux through each face. Since the charge is symmetric with respect to the other three faces, so solid angle subtended is also same by the face, top, this face and this face, right? So therefore, flux through each face is q divided by epsilon naught, the solid angle subtended by face divided by total solid angle, that is 4 pi, right? But what is the solid angle subtended by this face? That will be the solid angle subtended by other faces also. Because this face is at a distance of h from the charge, and this face is also at a distance of a from the charge, h is equal to a, and similarly this face is also at a distance of a from the charge because this is a cube. But we know the general formula for a rectangle is omega is equal to sine inverse LB divided by under root of L square plus H square times B square plus H square. In this case, when the charge is at a distance of H from one of the corners of the square face or rectangular face. As length is equal to breadth is equal to height for this case, that is cube, so that is suppose equal to a, say, then omega is equal to sine inverse, it is a square divided by, so putting the value here, it is 2a square sine inverse 1 by 2. Now this implies omega is equal to sine inverse 1 by 2 is sine of pi by 6, so omega is equal to pi by 6, right? Now we have calculated the solid angle here, so solid angle is now equal to pi by 6. So using this solid angle in this formula, so flux through each face is q divided by epsilon naught, then it is omega pi by 6 divided by total solid angle. So pi and pi will cancel, this 4 will go up here, so flux through face is equal to q divided by 24 epsilon naught. That is exactly the same as we have calculated by the symmetry method. Now since we have calculated the flux through each face, then total flux we can also calculate here. Phi total is equal 3 times, it is phi each face, that is equal so 3 multiply, so it will be q divided by 8 epsilon naught. So that is exactly the same as we have calculated it using the usual method. This method is more general. We can calculate the electric flux through each face when the charge is resting at different positions. We have taken here the corner. So in the next video, we will take the charge at the face center and calculate what is the flux through each face.